In this video, we will calculate the enthalpy of reaction given bond energies. So first, in most chemical reactions, some bonds are broken, some other bonds are formed, and it takes energy to break bonds. Energy is released when new bonds are formed. Therefore, the change in energy or enthalpy for a reaction is approximately the energy absorbed to break the old bonds minus the amount of energy released from the formation of new bonds. Remember, the internal energy for a reaction and the enthalpy for the same reaction are different because H equals U plus PV. Therefore, the enthalpy of a reaction minus the internal energy of a reaction is equal to the change of the product of pressure and volume. Fortunately, delta PV is very small. Usually it's less than 5% of the enthalpy of the reaction. Therefore, we often say, well, the enthalpy of reaction is approximately equal to the energy of the same reaction. Now let's work on one example problem. It's a simple one. We have a hydrogen molecule, a chlorine molecule. They react to produce two HCl molecules. We need to break a hydrogen-hydrogen bond. We need to break another chlorine-chlorine bond. And then we need to form two HCl bonds. Now, what we need to do is we tell ourselves it takes 432 kilojoule per mole heat to break a hydrogen-hydrogen bond. So we need to absorb this amount of heat. We need to absorb 239 kilojoule per mole to break chlorine-chlorine bonds. We will form two HCl bonds, and the formation of these two HCl bonds release this much energy. So this amount of energy is absorbed. This amount of energy is released. We take the difference, we get a negative number. Overall, the reaction is exothermic. The reaction releases heat. The enthalpy of two HCl molecule is lower than the sum of the enthalpy of H2 and that of Cl2. The commonly accepted value is negative 184, so this approximation is not too bad. Now let's look at the magnitudes of the three numbers. Why these two numbers are bigger than this number? Very simple. Hydrogen has a small atomic radius. Therefore, the bond strength of H2 is fairly strong. Let's look at Cl2. Cl atoms have fairly large atomic radius. Therefore, Cl-Cl bond is weaker than H2. How about HCl? This number supposedly is somewhere in between, but 247 is so close to 432. Why HCl also has a fairly strong bond? Very simple. This is a polar molecule. You have delta plus charge on hydrogen, delta minus charge on chlorine. Therefore, it's a polar bond. There's a little bit electrostatic attraction between H and Cl going on. That's why. Now let's work on a practice problem. So now we have one H2 molecule and 1/2 O2 molecule to form H2O. You may wonder, why did I say 1/2 O2 molecule? Well, if you're not comfortable with a fractional number of molecules, we can just say 1 mole H2 plus half a mole oxygen. We produce 1 mole water. We just need to look up the bond energy of H2, O2, and water. And then we do this calculation. 432 is the bond energy of the H2 molecule. And then because we're talking about 1/2 moles of O2 bonds, so it's 1/2 here. And remember, this O2 has a double bond in between. So you need to look up the strength of the OO double bond instead of single bond and plug in the number here. Okay, we form only one water molecule. But remember, there are two HO bonds in a water molecule. So it's 2 times the HO bond energy. So you find this value for O2, find this value for OH bond, and then you do the calculation. The answer is here in font size 2. So now, where do we find all those bond energies? Of course, your textbook, or you can go online. There's a very famous website, chemistry.com. LibreTexts.org, and then you can see a lot of values for those bond energies. Again, those are so-called average bond energies because you can have different values for OH bond. It's different in water than in, for example, alcohol. You'll get a different value for the OH bond. And also, when you're looking up the OO bond strengths, do not use 146, use 495. This is the bond strength in the O2 molecule. And also, sometimes we have different situations, such as this. CO double bond, it's 745, but there are exceptions. In CO2, this number can be a little different. Anyway, this is the website, and we have the average bond energies. You can simply Google bond energies, and that will lead you to many websites. Among them, this is fairly reliable.